I felt I wanted to go over one more half-lives. Okay, if you remember correctly, we did the half-life lab based on dice. Okay, where we had our 400 dice in the room, and it was basically a rolling of the dice, and we developed really nice graphs that looked something like that. Okay, and I want us to be able to handle some very, very simple, rational half-life questions. So I know some people are having some issues with a question like I laid out here. Let me just read it out loud. You have a radioactive isotope that has a half-life of 30 minutes. First question is how many half-lives will occur in 90 minutes? And then the second question is if you start with 28 grams of the isotope, how many grams will be left after 90 minutes? And you may be thinking, you know, you could look through old worksheets and notes and say, you know, this is a math question and, you know, there's no formulas. We didn't really do many of these. Okay, you know, how do I expect you to do this? Well, I'm basically asking in this fashion with some simple rational math. Okay, it's non-calculator based math. I'm asking you with this question whether you know what a half-life is. So to start off, if you don't know what a half-life is, okay, and that was the whole point of doing that lab, you are not going to be able to do this question, or it's going to be very tough. Okay, you'll have to almost get lucky in your understanding. Okay, so remember a half-life was the time required, or the time it takes, for half of a radioisotope to decay. Okay, and our graph, a little refresher, looked like this. Okay, I can do that a little bit better. Our graph looked like, went to the origin, looks like this, where, okay, where we started on the axis of being 100%. Okay, I believe in our lab we start with 100 grams, and we went all the way down to 0. Okay, I'm sorry, this is 0, and the time is on the bottom. Okay, and again, you have to understand what a half-life is. It's the time required, or the time it takes, for half of an isotope to decay, to disappear. Okay, our 50 mark is here. That's when half of the stuff is gone. It's at this point in time. Okay, I'm going to make up a time and say that this is 5 minutes. Okay, if I drew my quick graph correctly, and it actually looks like I got lucky here, I know I'm doing it freehand, this spot right here at 5 minutes is representing the first half-life. This point in time, just 10 minutes, okay, it's roughly double, is the second division. Okay, I'm basically dividing by half, because that's what a half-life is. It's for half of the substance to disappear. Okay, so my first half-life was 5 minutes. My second half-life was overall another 5 minutes, or 10 minutes overall. So this substance, according to my math, has a half-life of 5 minutes. That basically says that every 5 minutes, okay, every 5 minutes, you have half left. Half of it disappears, half of it decays. Okay, so every every 5 minutes, half of it decays, half of it's gone. And of course our graph went down to 0. Okay, but in the real world, where you're using billions and billions, okay, not using dice but using real atoms, it doesn't go to 0 quite as quick. Okay, it's more of follows the axis type graph. Okay, goes off not to infinity but to a very, very, very long time. Okay, for us, when we're dealing with a problem like I spilled out here, let's read it one more time. Let me clear off all those stuff. You have a radioactive isotope that has a half-life of 30 minutes. Okay? Half-life of 30 minutes. Again, what does that mean? Every 30 minutes, it gets divided in half. Okay, every 30 minutes. What this means, okay, I'm just going to focus still on this one statement. What this means, if I put my graph back up, that the first half-life would be at 30 minutes, because that's the half-life. The second half-life, okay, which would be roughly there, would be at 60 minutes. Okay, if I start at 100% or 100 grams, I would have 50 grams, I'd have 25 grams. Every half-life is 30 minutes. Alright, I'm going to go to 90. My graph is a little off scale now. Okay, I have to assume that it's over here, even though, of course, it's a little off scale. I'm basically saying that this goes to that. This goes to that. Okay, so every 30 minutes, because that's my half-life, every 30 minutes, my sample gets depleted by half. Okay, if I start with 100 grams of the sample, after 30 minutes I go to 50. Okay, so let me just track the half-lives this way. Okay, I'm just doing it rationally. If I start with 100, the first half-life, okay, which is 30 min, I go to 50. The second half-life, which is 30 min, or overall, you know, you could say 60 min, I go to 25. The third half-life, 90 minutes, I go to half of 25, which is 12.5. Okay, so every 30 minutes, I get divided by half. Okay, that's what that means. Alright, so let's carry on to our actual questions here. How many half-lives will occur in 90 minutes? Okay. And we have formulas. We're not going to work with formulas. I want to do this rationally. Alright, we didn't develop the formulas in class. I could give you formulas and then ask you much more math-intense questions. These are, like I said, non-calculator questions. So I don't really want to go there where we're actually dealing with formulas. Okay, I want us to just be able to do these questions based on your understanding of what a half-life is. If one half-life is 30 minutes, how many half-lives will occur in 90 minutes? Okay, 3. First one's 30, the second one's 60, the third one's 90. So overall, you have 90 minutes, an hour and a half. Each half-life is 30 minutes, so in your 90 minutes, 3 half-lives occur. Okay? Now, so we know now that we went through 3 half-lives. Okay, so how many occurred? 3 half-lives. So we know we went through 3 half-lives. What does that mean? Well, it means 3 divide by halves. Okay, 3 divisions by 2. Okay, by definition, that's what a half-life is. It's getting divided by 2. Okay, 3 different times. So now I'm going to go and talk about the second phase. Alright, the second question here, the second phase is, if we start with 28 grams of the isotope, how many grams will be left after 90 minutes? Okay, there's my 90 again. Well, it's basically saying how many will be left after? Okay, how many grams will be left after 3 half-lives? If I start with 28 grams, how much is left after 3 half-lives? Well, if I start with 28 grams, my first half-life gets me to 14. My second half-life gets me to 7. Like I said, you can do this without a calculator. My third half-life gets me to 3.5. Okay, grams. That's my answer, 3.5. 3 half-lives is 3 divisions by 2. Okay, again, I can't stress this enough. I know we didn't get any fancy formulas. Okay, you don't need that. The whole goal here is to use your head and to rationalize just on your knowledge of what a half-life is. If you don't know what a half-life is, you're not going to do well on this type of problem. Right? You should be able to figure this out on the fly and rationalize it just on your understanding of the definition of what a half-life is and your experiences from that lab.